Example 2. Scuba diving. A diving tank manufacturer finds that its smallest tank averages 35 minutes of oxygen. Assume that the distribution is normal with a standard deviation of 2.5 minutes. If a random sample of 25 tanks is selected, find the probability that the mean of the duration of oxygen is between 34 and 36 minutes. Okay, so again, we're going to use the central limit theorem here because we're dealing with a certain number of random samples of the whole. So what we know is on the population, the mean of the population is 35 minutes. And the standard deviation of the population, or the whole, if you will, is 2.5 minutes. Now, we are going to look at a random sample of 25 tanks. So that's our N. So N is 25 tanks. And we want to know the probability that the duration of oxygen is between 34 and 36 minutes. So we want to know what's the probability that X bar is somewhere between 34 and 36. That's what we're really trying to solve for here, is this probability. Okay, so let's start here. We're gonna have to have two Z values, as you can see here. I'll use my calculator to show you this. We have a mean of 35 with a standard deviation of 2.5. The number of samples we're looking at was 25. And I'm gonna leave off the mean here for a second. And so I'm gonna zoom in here. And so here's our normal distribution. But you're looking at it from 0, not from the probability of 34 to 36. So if you want to see it that way, what you'd have to do is go back up here, the normal distribution, and say, okay, our mean was 35 with a standard deviation of 2.5. And from here, we'd say, all right, what's the probability of it being between 34 and 36 minutes? Now, once again, you're looking at my curves and they're not matching, which means this must not be correct here. So I'm going to take this off again. I just wanted to show you that. All right, so we're back over here, and let me zoom in on this one. And so our x-axis is just not going to belong with this one. So how do I get my values? Well, if you remember last problem, what we did is we said, okay, let's talk about the standard error, or the standard deviation of the population, if you will. That was calculated by taking our original standard deviation, which was 2.5, and dividing it by the square root of the number of samples, which is the square root of 25. So when I simplify this, the square root of 25 is 5, and 5 goes into 2.5 times 0.5 times. So that would be called the standard error. And so now, if I want to find my Z value, and I'm going to have to find two Z values. You might have saw my calculator for a moment. Let me leave that off. I'm going to do, we'll say Z equals, what you do is you take your X bar. So I'm going to look at two different values. I'm going to look at 34 first. 34 minus the mean of 35 divided by the standard error, which is 0.5. So 34 minus 35 is -1. When you divide that by 0.5, you get -2. You can type that in the calculator if you don't believe me, but that's the algebra there. But we don't have just one Z value. We're actually going to have two. So I'm going to call that Z1, and here it will be Z2. So Z2 is going to equal the value 36 minus 35 divided by 0.5. Well, this calculation is nearly the same. 36 minus 35 is +1 now, not negative, but positive. And so when you divide by a half, we're going to get the value +2. And so ultimately, if you want to look at this as a normal distribution, your standard normal, this would be 0. And what we're looking at is we want to know what's the probability of the area being between the Z value 2 and -2. That's truthfully what we're looking. If this is the Z values, that's where we're looking for this to get the probability. So I'm going to say from -2 to +2, the probability of having, when we draw 25 tanks, the mean of those tanks being somewhere between 34 and 36%, or 34 and 36 minutes of oxygen is about 95.4%. I guess I rounded to 2 decimals before. I'll do the same here. This is the probability of this, probability that the amount of oxygen in terms of minutes, the mean of this sample is between 34 and 36, is approximately, that's how you would write that, 95.45%, which is a really good shot. That's a really good chance of having that mean there. So now I'll let you try one. Stop the video if you need more time, and you might have noticed, but you do not need to go normal distribution. You can use the central limit theorem with your values to solve here. When I typed in mine, let me see where I got the mean of the sample. What I would need to do for the calculator is to first put a 34, and I would have got that -2 value, which went there, and then you would do it again. Well, what about at 36? And got +2. I never completed that in the calculator. So that's how you could have got the -2 and +2, is just by changing the mean of the sample to those boundary values of 34 and 36. All right, your turn.